Hey guys, hope everyone is doing good. So I am DM Vinayaka and welcome to the Professor of Pharmacy channel. So in today's video, we're going to discuss about the Pitot tube and rotameter. These two devices we didn't cover in previous video. So in today's video, we are going to cover in these two. So firstly, start with the Pitot tube. So Pitot tube is an instrument that is used to measure the velocity of fluid. So what is the meaning of this sentence is that, like in order to measure the velocity of fluid, this Pitot tube is used. And it was invented by a French engineer like Henry Pitot in 18th century. So 18th century में like Henry ने invent किया था Pitot tube को. And this Pitot tube is widely used to measure the boat's water speed, airspeed of an aircraft, and in industry for measuring the fluid velocity. So, coming to its principle, it is also based on the बर्नौलीज थ्योरम. हम लोग पिछले वीडियो में पढ़े थे कि बर्नौलीज थ्योरम क्या होता है, उसका इक्वेशंस क्या है. So I'm just going to say in a short form, like in Bernoulli's theorem, we studied that if the speed increases, the pressure will be decreases. And here, the speed is nothing but the velocity. So if the velocity increases, the pressure will be decreases and vice versa. Okay. So it works on the principle that if the velocity of the fluid at a point becomes zero, so pressure increases. इसका मतलब यह है कि एक पॉइंट पे वेलोसिटी जीरो, मतलब वेलोसिटी जीरो हो जाता है, तो क्या होगा? Automatically the pressure will be increases. On the other side, the other tube which is used that measures the static pressure, so the pressure difference between dynamic and static pressure is measured by the manometer, and this total pressure is known as stagnation pressure. तो क्या होता है? एक ट्यूब होता है, उस ट्यूब का ऊपर दो अटैचमेंट्स होता है, लाइक वन ट्यूब फॉर द मेजरिंग ऑफ द स्टैटिक प्रेशर एंड द अदर ट्यूब विच इज द पिटी ट्यूब which will measure the dynamic pressure. So the pressure difference in between these two tubes is known as a stagnation pressure. Okay, so that is the total pressure actually. So here, as you can see, stagnant pressure is equals to static pressure and dynamic pressure. So static pressure plus dynamic pressure will be the stagnation pressure. So the equation will be P stagnation is equals to half into rho V square plus rho into static. So after slowing, the equation will become V is equals to square root of 2 into P stagnation minus P static divided by rho. And here the V is nothing but the velocity of fluid and rho is the density of the fluid. So this is the equation for the Pitot tube. So in coming to next point, that is construction. Pitot tube consists of two hollow tube where one measures the static pressure and the other measures the dynamic pressure. And this Pitot tube is a cylinder which have very small hole by which fluid enters, and there can be two more holes in the Pitot tube which act as a static pressure sources. तो इस construction को समझते हैं अभी. So this is the Pitot tube in which one hollow shape is there and the other tube is there. Okay, so this tube is for the measuring the static pressure and this tube is for measuring the dynamic pressure. So the pressure difference in between these two tubes will be known as a stagnation pressure. Okay, so we will get into detail after reading the working. Okay, I will explain after reading the working. So working, the Pitot tube installed, so fluid enters inside this because it is enclosed. So velocity becomes zero and the pressure difference between static pressure and dynamic pressure is measured by manometer. इसको समझते हैं by this diagram. So assume this is a pipe in which the water is flowing. This tube is for measuring the static pressure and this is the Pitot tube, okay, which is installed inside the pipe. So what will happen? The water will be flowing. So before entering into the Pitot tube, the waters have some pressure and some velocity. So in order to measure that, we have this static pressure measurer in which we will measure the static pressure, like how much of pressure is there before entering into the Pitot tube. That will be measured by this tube. and assume the pressure is reached up to here. Okay. Then what will happen? The water will slowly enters into the Pitot tube, and here the Pitot tube have a small hole or small orifice in which the water will be entered. So after entering here in this Pitot tube, what will happen? The pressure will be zero because in this Pitot tube there is no pressure. So what will happen? The velocity will be zero. So if the velocity or speed of the water will be zero, what will happen according to Bernoulli's theorem? If the speed becomes zero, then the pressure will be increased. So in between these Pitot tube inside, the velocity will be zero. So automatically the pressure will be increases. So the water which is entered inside the Pitot tube will automatically rises above. Okay. For example, assume in the static tube, the water level is up to here. Okay. And when the water enters inside the filter tube, because of the pressure increased, the water level will be increases. So up to here. So between from this level to this level, the some pressure difference is there because in static pressure, the pressure is different and in the filter tube, the pressure is different. So in order to measure these two pressure differences, we will use the manometer. Okay. That manometer, we can determine like how much of pressure is there inside the filter tube or for the water. And this Pitot tube can be used for both, not like the orifice meter and the venturi meter, where we will only measure the velocity of the fluid. Only the liquids we will measure. But in here, in Pitot tube and in the rotameter, what will happen? We can measure also the gases, like gases का velocity क्या है, उसका flow rate क्या है, उसका pressure क्या है, सब कुछ measure कर सकते हैं in the rotameter and Pitot tube. Okay, so this is the working of the Pitot tube, and this is another diagram of Pitot tube, which is in the enlarged picture. Like assume this is a Pitot tube in which there is a small hole or the small orifice in from which the water will enter inside the Pitot tube, where the velocity will be zero. Because of this velocity is zero, according to Bernoulli's theorem, the pressure will be increases, and then the water level also increases. Okay, and then we will compare both static pressure and dynamic pressure, and there will be some pressure difference which is measured by the manometer. So this is the working of the Pitot tube. Now let us know what are the applications of this Pitot tube. The Pitot tube is used to measure the fluid flow rate in industries. फ्लूइड का फ्लो रेट क्या है, उसका वेलोसिटी क्या है, उसका प्रेशर क्या है, वो सब मेजर कर सकते हैं हम लोग by from the use of Pitot tube, and it is widely used to measure the boat's water speed and air speed of an aircraft. बोट का वाटर स्पीड क्या है और एयरक्राफ्ट का कितना स्पीड में जा रहा है एयरक्राफ्ट, वो सब हम मेजर कर सकते हैं by using the Pitot tube. Okay, so now the advantages. The first advantage is very common, like it is economical and easy to install and does not have a moving part. And third is the it is very cheap. These are the advantages. And coming to the disadvantages, like soil dust particles can be easily obstruct the Pitot tube. क्योंकि Pitot tube का ऑरिफाइस स्मॉल होता है, उसमें अगर वाटर में कोई डस्ट पार्टिकल हो या सॉइल पार्टिकल हो, वो लाइक स्टक हो जाता है इन द ऑरिफाइस, so then the water cannot move inside further. So this is the main disadvantage of the Pitot tube. Hope you guys understand this Pitot tube. Now let us move towards the rotameter. Rotameter is also a device that is used to measure the flow of fluid. ओके, सो फ्लो ऑफ फ्लूइड को हम सिर्फ Pitot ट्यूब से नहीं मतलब रोटामीटर से भी मेजर कर सकते हैं. इट इज मेजर्स वॉल्यूमेट्रिक फ्लो ऑफ फ्लूइड इन क्लोज्ड ट्यूब एंड वॉल्यूमेट्रिक फ्लो रेट इन द वॉल्यूम ऑफ द फ्लूइड विच पासेस पर यूनिट टाइम. रोटामीटर का एडवांटेज ये है कि Pitot ट्यूब में हम लोग सिर्फ कितना फ्लो रेट है, कितना वेलोसिटी है, कितना प्रेशर है, वो मेजर कर सकते हैं. पर इन रोटामीटर एक एडवांटेज क्या है कि एक मेन एडवांटेज है कि ये वॉल्यूमेट्रिक फ्लो को मेजर कर सकता है फ्लूइड का. Volumetric flow is nothing but like in per time how much of fluid is passed the tube. मतलब हम डायग्राम की हेल्प से समझे तो अज्यूम कर लो एक ट्यूब है जिसमें वाटर फ्लो हो रहा है. ठीक है, तो एक हावर में 1 आवर में कितना वाटर फ्लो हो रहा है, कितना फ्लो रेट है उसका, उसको हम मेजर कर सकते हैं बाय यूजिंग दिस रोटामीटर. ओके, the definition of this volumetric flow rate is nothing but the volume of fluid which passes per unit time. This is the definition of the volumetric flow. Coming to its principle, it is the variable area meter which works on the principle of upthrust force exerted by the fluid and force of gravity. रोटामीटर किस पे वर्क करेगा? फोर्स ऑफ ग्रेविटी पे वर्क करेगा और अपथ्रस्ट फोर्स विच इज एक्साइटेड बाय द फ्लूइड, इन दोनों से वर्क करेगा रोटामीटर। इसका कंस्ट्रक्शन, it contains a tapered metering glass tube which contain a float which made up of the aluminum और glass। एक फ्लोट होता है जो अल्यूमिनियम और ग्लास से बनाते हैं, उसको हम लोग टैपर्ड मीटरिंग ग्लास ट्यूब में इंसर्ट करते हैं। इसका वो कंस्ट्रक्शन है ऑफ रोटामीटर। नाउ लेट अस सी द डायग्राम द रोटामीटर। So this is the diagram of rotameter. This is a tube in which the float is there. So this is the tube and this is the float which is made up of the aluminum or glass. This is the another diagram from which we can simply understand the working. This is the float and this is a tube which made up of glass. Okay, this is the construction. After reading the working, we will again come into the diagram. So then we can understand better. Now, the working. Fluid enters the tapered tube. Some fluid force on the float upwards and some fluid from the side. Two forces act on this case, and upthrust force and weight of the float. These are the two forces which will act on this case. So when equilibrium is established, so the float will comes to rest, and this reading is measured by generally from ending point of the cap of the float. So इसको हम समझते हैं वर्किंग को by the use of the diagram. So this is the diagram of the rotameter. This is the tube in which the float is there. So this is the float. Okay. So in this, what will happen? We will pass the water inside this tube. Because of the force of the water, what will happen? There will be some pressure. And because of this pressure, the float, which is made up of aluminum or glass, will start to move upwards because of the pressure of the water. And because the float has some weight, because it is made up of glass or aluminum, it will have some specific weight. And because of that weight, what will happen? Due to gravity, it will again comes down. So this movement from downwards, upwards, upward, downwards, this force is known as an upthrust force. Okay. So the what we studied in the principle, like in the rotameter, is based upon two main forces, that is gravitational force and the upthrust force. So upthrust force is nothing but the movement of the float upwards and downwards. This is the upthrust force. Okay. So जब हम वाटर को फ्लो करेंगे इस ट्यूब में, ड्यू टू सम प्रेशर, ये फ्लोट, एल्यूमिनियम फ्लोट या ग्लास फ्लोट क्या होगा? मूव होगा upwards, and due to gravity again it will come down. Okay. So this up and down movement will be there until it at certain point it will attain equilibrium. Okay, at that point we will measure, like here will be the scale, one scale will be there beside the tube. So at equilibrium, when it will attain the equilibrium, at what point we got the equilibrium, we will get to know. Okay, that point we will mark as a pressure difference or the rotameter's point. Okay. So in this is a simple diagram, this is a complex one. In simple diagram, as we can see, this is one cylinder in which the glass tube is there. In the middle, the float is there. So when the water will enter from the bottom, and when the water enters, due to some pressure, the float will be moving upwards. So and due to gravity, because the float has some weight, because it is made up of aluminum or the glass, it will again come downwards. So because of this upthrust force and due to gravity, what will happen? It will move up and down. At certain point, it will attain equilibrium. At that point, we will mark it as a scale. From the scale, we will mark it that point. Okay. So this is the simple working of the rotameter. I hope you understood by this diagram. Next one is the applications. Like what are the applications of the rotameter? The common application is the to measure the fluid flow of gases and liquid. Like orifice meter, वेंचुरोमीटर में क्या होता है, सिर्फ हम लोग वेलोसिटी ऑफ द फ्लूइड को और फ्लो रेट को आइडेंटिफाई कर सकते हैं, फ्लूइड मतलब लिक्विड का। पर इन दिस रोटामीटर एंड पीटो ट्यूब क्या होगा, हम लोग फ्लूइड फ्लो ऑफ द गैसेस एंड लिक्विड बोथ बोथ का हम लोग वेलोसिटी कितनी क्या है, लाइक फ्लूइड रेट क्या है, वो सब समझ सकते हैं और मेजर कर सकते हैं. दिस इज द मेन एप्लीकेशन ऑफ द rotameter. Coming to its advantage, no external pressure required for volumetric flow rate. Volumetric flow rate is nothing but the volume, how much of volume of the water passes at per unit time. That is a volumetric flow. Okay. So because due to that, no external pressure is required in this rotameter, and it is suitable for small flow rate, and cost is very low, and it is economical. These are the advantages of the rotameter. And the disadvantages, it depends upon gravity. So rotameter always operated vertically. So here rotameter में gravity का force work होता है. So in order to do that, in order to like do the gravity, like letting do the gravity's job, what we have to do, we have to keep the tube always vertical position. वर्टिकल पोजीशन में ही रखना पड़ता है क्योंकि ड्यू टू ग्रेविटी एक्ट होना चाहिए ना इसमें. तो ड्यू टू दैट वी विल कीप दिस इंस्ट्रूमेंट और दिस डिवाइस वर्टिकली ओनली. So that is the main disadvantage. And the other disadvantage is that the glass tube might break. Like a glass tube होता है, as I said, as I showed you guys in the picture and in the diagram, एक glass tube होता है जिसके बीच में एक float होता है. So there is a chance that due to the movement of the float, the glass might break. It's not like definitely it will break, it might. There is a chance. So that is the another disadvantage of this rotameter. So this is up for today's guys. And this completes the first chapter, that is law of fluids. तो इस वीडियो में हमने क्या क्या पढ़ा. हमने पढ़ा था कि पीटो ट्यूब क्या होता है, उसका प्रिंसिपल, कंस्ट्रक्शन, वर्किंग क्या है, और रोटामीटर का भी सेम, एंड आल्सो द एडवांटेजेस, डिसएडवांटेजेस एंड एप्लीकेशंस. So this is it, and this will complete the first chapter. And in next video, we will discuss the next chapter. Okay, that is size reduction and all. We will get to in detail with that. Okay, I hope you guys understand well. If you have any doubts, you can put the comments on below. Okay.